right, ladies and gentlemen, welcome back to AP Chemistry with Mr. Kenton. This is the last video for Unit 4 covering redox reactions, and specifically we're going to be looking at balancing redox reactions. And that's exciting for one. I think this is a really neat thing that we have to consider. I'll also say it's very challenging. It's different. It's kind of long. And so that's why I split up the balancing into two different parts. Okay, we had the first video that covered 4.9 that really kind of introduced you to the basics of redox reactions. You know, identifying oxidation numbers, identifying whether something was oxidized or something was reduced, being able to look at reactions and determine, is it a redox reaction, right? So now I want us to consider, what does it look like to actually balance a redox reaction? Now, a big difference within redox reactions that we need to recognize is that when it comes to balancing them, we actually need to take into consideration two things, right? We need to take into consideration the conservation of mass. We do that in every reaction already anyway, so that's not going to be all that difficult, right? The amount of each element present at the beginning and the end of the reaction have to be the same. That makes sense, right? From a stoichiometry perspective, from a conservation of mass perspective, that makes a lot of sense. The second piece that redox reactions initiate is that there has to be a conservation of charge. And so, you know, the number of electrons that are lost by one substance need to be gained by another at the end of the process. And so this transfer and change of charge needs to be uniform throughout the process. So charge has to be conserved. Okay, and so when it comes to balancing redox reactions, we have to make sure that we're adhering to both of those pieces as we do this. Now, what we know is that there is a way to kind of make this a little bit easier for us so we can break it down and then get to a point where we can balance. And so a lot of times what you'll see in redox processes is that chemists will look at half reactions as a more convenient way to show these changes in mass and charge for an overall redox process. And it's exactly what it sounds like. What they do is they take the oxidation portion of the reaction, they separate it. They look at the reduction portion of the reaction, they separate it so that you can look at those particular changes that are going on in that redox process. Okay. Now, here you go. I know it's going to look very text heavy, so just kind of bear with me here. When we're talking about balancing redox reactions in acidic solution, right? So balancing redox reactions can take place really two ways. You can be in acidic solution or you can be in basic solution, right? I'm going to give you the rules for acidic solution, basic solution. There's one additional step that's pretty straightforward. And so as we're looking at this, we want to balance a redox reaction. They tell us it's in acidic solution. Then the first thing we want to do is we want to divide the equation that we've been given into two incomplete half reactions. We want to have an oxidation half reaction and a reduction half reaction. And remember, if you don't remember which substance is oxidized or reduced, remember oil rig or Leo the Lion says Gur, right? So once you have divided your equation into your two incomplete half reactions, your next task is going to be balancing each half reaction, right? And so, you know, certainly if you've got elements, if you can, you're going to want to balance elements other than H and O first. H and O are going to be kind of tricky, so like if you've got a metal ion and a metal, make sure you've got the same number of those on both sides of your process. So you do everything other than H and O first. Now, when it comes to balancing out your oxygen atoms, the way that we're going to balance out oxygen atoms in a redox process is by adding water molecules. Okay, so in order to balance out oxygens that are present, we're going to add water molecules. Once you've balanced out your oxygens on both sides of the equation using your water molecules, you can balance hydrogen. And hydrogen is going to be balanced out by the addition of H plus ions. That's where that acidic solution is going to come into play, right? So you've got your acidic solution, you've got your H plus ions that are there. So you balance the H's out by adding H plus ions. Once your hydrogens are balanced on both sides, then the last piece you're going to need to do is you're going to need to balance the charge of each reaction by adding electrons to the side with the greater overall positive charge, right? And so what that's going to allow you to do is to be able to neutralize your charges so that both sides of the equation, the products and the reactants, can be electrically neutral, at least charge can be conserved, I should say. So that charge can be conserved on your reactants and your product side. Okay. Once you follow those steps, then you compare the number of electrons that you have in your reduction and your oxidation process. If necessary, you might have to multiply each half reaction by a whole number so that the number of electrons lost is equal to the number gained. Once those numbers are reached, you then combine the two equations and you start simplifying where possible. You're going to start canceling things out that appear on both sides of the equation. You're going to simplify things. If that means that all of them get canceled out on one side, but there's some left over on the other, that's perfectly fine. And you're going to do that until you get to your final product. And then the last thing you're going to want to do is you're going to want to check the equation to make sure that there are the same number of atoms of each kind and the same total charge on both sides. Again, if your reactants started out with a +2 charge, your products need to end with a +2 charge, right? If your products end electrically neutral, your reactants need to end electrically neutral, right? And so those are the steps that you're going to have to walk through in order to balance a redox reaction. Now, I've got a separate video that has this worked out so that you can actually see these things applied. Definitely going to want you to go and watch that. But here's just giving you the rules, the content of how you would do that, and then there's the videos on like actually watching me work through that process. So hopefully that will also assist you as you're doing this. Okay. So that's how you would take care of a redox reaction if it's in acidic solution. Now, if you're told to balance a redox reaction and it's in basic solution, well, the good news is the steps aren't all that different. You're going to follow the same steps that we introduced on the previous slide. Whew, that's nice, right? Now, the big difference is because it's acidic, or it's basic solution now, we need to remove the H pluses. And so in order to remove the H pluses, all you do is you add hydroxide ions to both sides of the equation. And what happens is you add enough hydroxides to neutralize the H pluses. And what that does is you form new water molecules, then you combine your terms, cancel out when appropriate, and then you're finished. Then you're all done. So it's really just one additional step kind of at the end if you're dealing with something that's in basic solution. Okay. Now, that being the case, like I said, I think before you go and try these as an example, I am going to have a video that's going to be posted that shows you how to balance redox reactions. I would say watch that video first, and then once you've watched me kind of walk through how we do that process, then try these on your own. Okay, so it asks you to identify the oxidation reduction half reactions and balance each of the following. And they give you 3 separate reactions, right? Assume the first 2 are in acidic solution, and then the last one is in basic solution. So, watch that other video, and then practice this on your own, and then bring your answers to class, and we'll talk about what you guys are able to get. I might also make a video of me working out each of these for you guys to check over your answers. So, be on the lookout for that as well. And ladies and gentlemen, that is the end of Unit 4 of balancing redox reactions, introducing different types of reactions, all that jazz. We've now come to the end of Unit 4. I'm sure it's a bittersweet moment for you guys, but I hope this video has been insightful. Hopefully it's helpful. Please let me know if you have any questions, and I look forward to seeing you guys again soon. Take care.